Today I'm going to start this episode with a magic trick. Hold your applause. What up YouTube? Welcome back to another Robot Wars video. Today we're actually going to be doing something slightly different because I don't know if you saw recently, I've actually acquired a 3D printer, which is just sat over there. I'll show you in a moment. So I'm actually going to have a go at 3D printing some mounts. So if you can see, this is, if I move the chair, that's my very crude drawing over there of what measurements I've made of the motor. The motor's just, at the moment, I'm dropping stuff, is just on its own here. So I've taken him off Graticus. So we'll jump over to the software, I'll show you what I've done, and then we'll have a go at printing it. So here we are then in Fusion 360. There's two mounts. There's this one here, which is for the rear of the motor, which is just a simple circle. And there's this one, which is one with a indent, because the motor actually has a part indent at this point on the front of the motor. I'll just briefly go for, I'll just do this one because the process is the same with both, whereas this one's got an extra step in it. So I basically started off with, can grab it, there we are. Start off with a sketch. If it's actually, am I showing sketches? No, I'm not showing sketches, there we are. So I just started off with a simple sketch. I made a rectangle, made a circle in the middle of it, and then I've just drawn across at the points I've measured on the robot itself. I've measured the diameter of the circle, this part. I was about to point at the screen then. I measured the diameter of this, and then I measured from flat to flat. That's why you could see on the board there was flat to flat. And then I just minused that and halved it, and then that's why I got this value here. And also measured from here to here. And it's about 18 millimeters. So I know that I've got the measurements roughly right. Whether they will be right, we'll see. And then I went on to extrude that. So I turn off the sketch. Extrude that into 20 mil or 2 centimeters. Then I made another sketch. Is it showing it? There's sketch number 2 there. Another sketch on top, which is just, I made a line across, made it a construction line, and then plonked 2 circles in the middle of it. It's 6.3 mil. The bolts I've got are 6 mil, but I'm adding a 0.3 mil for tolerance on top of that, so that's why there's 6.3 mil each. We'll see how well that goes. And then I just dimensioned it from here of, I think 8 mil. I think I put it from here just so it's centered and it's a good ways out from the edge. And then moving on, I then just extrude cut. I'll get rid of the sketches. Extrude cut all the way through to make a hole for the bolts to go through. And then what else did I do next? Oh yeah, the final step is I made another sketch, and this sketch is just a simple line that goes through all the way through on top of this face. And then I used the split body feature to then use that line as a tool. If I turn that off again, learn that as a tool for the split body, and then I split these into 2 different bodies. So then here you've got the bottom half, top half. That's just so I can print them individually. That's an optional step. If you just moved them apart and then exported the whole body as one, you could print it like that. But this gives you a bit more flexibility on how you want to place it on the print bed. So yeah, so that's basically it. So we'll have a look. I'll do a quick clip of it printing, and then we'll see how it fit. So here we are then. This is the completed mounts, nicely printed. And surprisingly, I've got it like almost bang on first time. There's a few issues. If I move these ones off for a sec, you can see this one here. If I tilt it that way, you can see it's still, even though if I hold on to it, it's still loose in there. So I probably need to reduce that by, say, a mil, and that'll be pretty smack on. The actual, I was surprised, the actual groove on here fit really well. One thing to note, this one actually has a slight, I didn't know this before, has a slight divot or dimple or whatever you want to call it there, which stops this from sitting flush. So what I've had to do, if I look there, you can see I've had to just file a dimple out. That was just done with a triangular file because that's the only one I had at the time. And then now that sits on top of there. But as you can see, even with that cutout, it's still not quite like without. If I pick it up, it sits, if I can find the groove, it sits nice and flat, which is what you want there. But even with that nice flat and that really well positioned, it could do with being a mil smaller. So it could be doing a little bit smaller. So what I'm going to do, I'm going to jump back over to the software. I'm going to reduce this one by about a mil, the circle of it, and I'm going to add a sort of divot or whatever into that and reduce that. The distance between these two flats, probably just reduce the circle size by about a mil, and then we'll see how that works. One other thing to note is that these holes are actually perfect. They're 6.3 these are, and with that, with the tolerances, fits on absolutely perfectly. There's like very little movement in there. There's barely any at all. So that's pretty much perfect. When that's clamped down, that'll be perfect. Obviously I need to re-drill these because the originals were a slight bodge, shall we say, but I think that's a win. Okay, see, there. I'm African. Yeah. Shouldn't be your fucking speaking skills are way below your. No, hang on a minute. Your mental skills are way below your speaking skills. Well, that just proves it, I think. So here we are then back in Fusion 360. This one's a relatively easy fix. All I've got to do is go back to this original sketch, go edit sketch, and just make this diameter smaller. Because at the moment it's 36. So, is a mil too much? Okay, I've decided that a mil might be too much. I'm going to take baby steps here. I don't mind using a bit extra filament to get the perfect part. So, we'll do 35, not 38, 35. My mic's in the way of the thing, so I can't see. 35.5 for the circle. And because that we already sort of define this by the center point, that should still be in the center. So that's all good. So all we're going to do is stop sketch, and that's the only modifications we need to do to that one. That is literally it. The slight sort of change here, I don't think it'll affect too much in terms of how the motor sits, because it's only, each end will only be 0.25 of a difference. So it won't matter too much. We'll see how that comes out. We'll just jump over then to the other thing. This one's a little bit more awkward, because when we go back to the original sketch edit here, see we've got these dimensions dimensioned by here, and these are the ones we'll want to be smaller. In theory, I'm learning as you are at the moment. If I can actually click that value, there we go. 29 at the moment, so we want to go down probably a mil. So if we do 28 on that one, in theory, that's all we should need to do. These didn't move, so we've come down a mil, so we'll have to do, these are 11.3, so we'll do 0.5, so we'll do that, because my maths is terrible, we'll do just minus 0.5, and then, same here, minus 0.5. So we got 10.8. There we go. That is probably right, to be fair, but I don't mind maths. This is why I use calculators. Right, so now with those changes done, I think let's just do one check before we do. This bar here needs to be around 18 mil. So if it's not, we know we've got, yeah, 17.8 mil. That should be still pretty bang on. So as long as that's around the 18 mil mark, that should fit in there fine. We've just reduced the gap between these two here by reducing this. So the next thing, I nearly forgot, we need to add a bit of a dimple or a divot or whatever you want to call it in this, probably in the top piece. Yeah, because we want it to sit nice and flat on the bottom one, so we'll put it in the top one. So here, what we'll just do, we'll create a new sketch, and I've measured it, and it's 5 mil to the center of the thing, of the line. So if we'll just do a center point circle, yep, and then the actual divot is about 3 mil. So if I put in 3 there, and then that's bang in the mid. Can you just do it, please? Thank you. That's bang in middle, and then what we'll do, we'll dimension this. Press D. We'll dimension the center of that to this point here to be 5 mil. That looks about right, actually. Brilliant. That's all we need to do sketch-wise. Stop the sketch, and this piece here, we'll just do extrude, and we'll do an extrude cut. So if I do it this way, and we'll just make it so, ooh, just goes through all the way through, and just extrude cut that part there. And then, okay, and that's our modification finished. Hopefully that should be all that's needed, and hopefully I've got it in the right frickin' place. So we'll see what goes on, we'll see how the print comes out, and we'll be back in a moment. Okay, here's the version 2 prints, and I bet some of you were absolutely screaming at me, weren't you? I made such an idiot mistake. These were supposed to be bigger, not smaller. The groove fits in there quite nicely. That's one good thing. But as you can see now, the gap's gotten bigger rather than smaller, and I have to like compress them to get them to fit in there properly. So that was a bit of a boo-boo, so I'm having to reprint those. These were very close, the rear mounts were very close indeed to, because now if I hold on to them, it actually does grip it. You can feel it, I can feel it gripping slightly, but it was just not quite enough, unfortunately. So what I'm going to do, you don't need to see me do it again, because you've already seen me do it once. But what I'm going to do, I'm going to make that bigger, I'm going to make that 0.5 smaller again. We should have just jumped to the mill, shouldn't we, really? But never mind. And then that should grasp on there quite nicely, because that's almost holding onto it there. This, it doesn't matter if this one's a tiny bit loose because of that flat, it can hold onto it, it can't move. And plus if this is grabbing all of it well, then we should be good. So I'll get those printed, and then I'll see you after that. Alright then, I've printed the 2 updated versions. We're on version 3/3.5. The reason it's 3.5 because I've modded this slightly, but I'll show you in a minute. This now fits perfectly. That there, if I can actually get it in frame, fits in the groove nicely. It fits around there nicely, and when you tighten it down, it tightens nice. can't move on that. And then this rear one, what I did, I actually lowered, so this part here is slightly thicker than that part here, because it was on a slight angle. And I'll just include an image here of the getaway I got of levelling it. But it worked well, so that sits nice. There's a slight gap there, so it'll clamp down nice. But if it shows signs of breaking, then I'll just I'll just make that circle smaller by 0.5, or 0.25, I think, because I already lowered it by 0.5 on that last one, and it was slightly too much. But that's quite good. I think that'll clamp hold of that metal quite nicely. So next step, we're gonna take it out into the garage, rearrange this a little bit, and then remount the wheels so they're actually got the right holes in the right places on here, and mount it so they're in the middle, so the wheels will be central in the robot, because that's how I'm gonna have it in the actual final finished robot, so it can like do spins and things, and it should be quite maneuverable. So we'll go do that now. Okay, as you can see, it's been a little while since the last segment, about 2 months in fact. Basically Christmas happened, you all know the story. Basically I've decided, I can't remember what I said in the last one, but I decided that I wasn't going to put them in the middle, because it's a test build, and the battery, see, I already tried where the battery was going to go. I think that's just going to make it tilt, so it's constantly driving around like, and we don't want that. So I'm just going to leave it as it is, being as these two holes, if I can actually get it in shot, are actually coincidentally perfect size for the front mount, and they're already in the right place, so that'll do. And then I'll just kind of probably re-drill these, and hopefully I might turn out the same with these two as well, but I haven't tried them yet. So they basically go in. These bolts are too long. I will get the right size ones once I get the in. There we go. I'll get some right size ones that actually match, like, is the right length later. So these go on, and I've got the bottom half of this one, because I've noticed these have got the different shaping. So this one can go in the bottom there, and fits lovely over those. And then the drill will then fit inside that, whatever. I'll show you after I've drilled them properly, but yeah. Actually, no, I'll do it now quick, because I need to test kind of where the area is anyway, so I can find out where to drill the next ones. You know, the front mount fits marvellously, as you can see there. I'll try and see. Oh, there we go, you see a bit better like that. Fits perfectly in there. And now I'm just going to get the other mount, get this one. And incidentally, if you're interested, I will release these mounts on Tinterweb, if you want to use them in your robot, if you're using similar motors. Just to note that the rear one, which I probably should have put on first, but never mind, the rear one, the rear mount, is, the bottom half is about 1 millimeter shorter than the top, so this stays level, because see, when that's running, I don't know if you can see, it runs pretty much straight, which is what we want. So if you put it the other way around, it'll still work, it'll just be slightly, you'll have a slight camber on the wheel. But yeah, there we go. This is the one I'm not sure whether it's going to split or not, but we'll deal with that once we get to it. But just need to mark this now. Stop, hammer time. So I found the easiest way to mark these at the moment is just to get the size smaller than the drill bit I'm going to use. Try and get it in the hole, and just make sure it's kind of centered there, and just give it with my, it's a magnetised hammer. Who'd have thunk? Get it in, and then just give it a whack. Miss. And then the same the other side. One of those holes will be right. Obviously you do this on a desk. I'm trying to do this while showing you. I probably should have just lent it on there really, shouldn't I? But never mind. Now you lot being all clever people and not absolute bodge artists will not have to worry about having holes in your bloody way. But you can see the mark there, and there's one right next to it, so we'll have to be a little bit, give that a bit of a careful drilling. That sounds terrible, doesn't it? So now I'm just going to give this a whirl on the old drill. Incidentally, got a nice fancy new drill press. Actually bought it for me dad for his Christmas, so that was nice. So we'll give this a whirl and we'll see what we can do. Light sources by Will Caddy, patented. Right, let's get these drilled. I couldn't see, so I went and got a torch, and this is the best way I have of mounting it. That's the first one done. Certainly more clean than the first one I tried. Incidentally, I just went over it as well because I couldn't quite see the mark. I went and got just a punch and give it a whack with a proper full big punch. And oh, there's spaghetti on the thing. So we'll have another go with the other one. This one's going to be tricky, so we'll see what we can do. Stuff everywhere. Yeah, I think we got away with that. It's not going to be the best fitting on the rear one for that one, but who knows. And don't do this, by the way. I'm only doing this because it's plastic and I know it's not going to be really hot. If you were doing that with wood, that would hurt a lot. Right, so let's get rid of the torch. We don't need it so much anymore. We'll have a go and see how I rear mount, whether it, which one did I have? Which one's the tall one? This one. That one's the thicker one. Yeah, I know what I mean, no one else does. Yes, look at that. Slightly wonky, but it's fine. This, like I said, this is the test bench. We'll be way more precise. I'll actually measure and put lines and all sorts of stuff in the proper thing. It's a moment of truth now. Let's see whether it's gonna. I know the front one will be fine. Pretty sure about that. But the rear one, I'm wondering whether the rear one's going to crack. And let's see if we can get you to. Perfect, look at that. So now I just get the one with a little cutout on it in place. That's already looking way more professional than it was before. Where's the nuts? Again, please no comments. I'm gonna say that and then everyone's going to comment saying now he said nuts. These other ones on. These are actually not too bad. I thought these were going to be like mega long, but they're actually not bad. Like that's obviously a bit long, but these rear ones are pretty good. Gives me a bit of room to either put nylocks on or have two to like lock it off. But I think nylocks will be better. Doing well. The top one. This is the one I'm worried about, because there's a slight gap there. I'm pondering whether I should have put a slight gap in. That is not the right angle. I'm surprised by this. Surprised, very surprised. honest to God, would have put money on that snapping in there. It is. I can hear it. I'm not going to go any further than that, but that does tell me, because that bit there, I'm actually going to slacken it off slightly. That does tell me that that gap's too big, at least for this stuff. It might be alright because the I should probably explain a bit better. I'm gonna buy some of the Polymax, by Polymaker Polymax PLA, which is 9 times stronger than regular PLA. Well, this is PLA Plus supposedly, but it's the cheapest cheapest stuff I could find, so I could prototype things with. But although I can't tighten that all the way, that is solid. That is not going anywhere. And also the nuts coming off, lol. There we go. That's on there pretty damn sturdily. So I'm happy with that. Right, so I'm going to go print another set of these. This I'm going to modify slightly. Because I'm going to leave that one the same because that worked perfectly, that did. And I could tighten it down pretty well. And this is only standard PLA as well, so that's a testament to that one being fine. This one I'm going to reduce the circle size by about 0.25 mil. So it's most of the... it'll flex ever so slightly, perhaps, but there won't be any gap. And this front one will stop it from spinning anyway. I just want something to grasp hold of that decently so it doesn't spin. But as it is, that's very good. So let's bounce back over to the printer and get the other ones done. So here we are then. I've done the last of the 3D prints, and I must apologise because I'm actually doing a voiceover in post for this shot, being as my brother, being a wonderful person he is, decided he was going to start angle grinding right as I did the shot, so you couldn't hear a word I was saying. Basically in here all I'm saying is that I'm going to mark, drill and fix them in the same way I did before, so it's time-lapse time. Here we are then. Both the motors are mounted. The second version of these fitted a lot better. There's still a tiny bit of cracking, but when I use the the Polymax PLA or the PC Max, if I can actually get to print that high, those will be quite strong. But I think that was the one I did. But yeah, so I'm going to go back upstairs into the office, darling, and rebuild it, and we'll see how it goes, and see if they snap horribly. Alright then, we're ready to give her a whirl again. Let's just hope nothing blows up. Whoop. Yeah, I fucked them up. Fucked them up backwards, hang on. Try again. There we go. Right, now that's working. Shall we give it a whirl and see what happens? I'll think so. So there you have it in the last segment. A bit shorter than I wanted to do, the camera died, but it actually works really well. I don't know, in combat it might be a bit different. It might be like, and explodes, but being as I'm planning on putting the Polymax PLA, using that for these parts, we should be fine. And then hopefully there might be a couple of videos coming up, me upgrading my 3D printer to an all metal hot end, but maybe, we'll see. Also a heated enclosure. Stay tuned on that one. So in the next video it'll either be me designing and printing the little mounts that I've got in mind for the speed controllers, because I don't know if you noticed, but everything's flapping around like flip-flops now because all the Velcro's come unstuck. So the next step would be looking at printing mounts for those, or it'll actually be building a prototype either out of wood, or if I decide to buy the actual plastic and just go in straight for it. But we're also looking to, in the next few episodes, how to template, so things you design in SketchUp or Fusion 360 as I've started using, getting those out into like little templates, printing them out in full size, so then you can just cut around them, stick them on and cut around them, which will be cool. So not sure what's coming next, but all good stuff to come. So thank you very much for watching. If you enjoyed, please like, comment, subscribe. It helps me out a lot. And I shall see you next time. Ta-ta!